Okay, so today we're going to cover scientific notation. It's lesson 710. So in this lesson, we will learn to use scientific notation. Now, when you take science classes here, maybe chemistry or anything where you're going to be using really large numbers or really small numbers, your numbers can be written in scientific notation, so you don't have to write a whole lot of zeros on your paper. Now, in this lesson, not only are we going to learn how to transform numbers from standard form to scientific or vice versa, we're also going to learn how to multiply and divide numbers in scientific notation. So before we begin learning how to multiply and divide, we're going to actually learn how to transform the numbers into scientific notation. So the correct format for scientific notation is you need to only have one number in front of the decimal point. So it's got to be a number between 1 and 10. And then it's going to be multiplied by some power of 10. So what we're going to do is count how many times we move our decimal point so that it's behind a number that's between 1 and 10. So for example, if I do example 1 here, my number 58, 1, 2. Okay, so now what I'm going to do is I'm going to count how many times it's going to take me to move my decimal point so that I have a number between 1 and 10. And essentially, I want one number in front of my decimal point. So I start at the back because this does not change the value of my number. And now I'm going to count the jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now my number is 5.812. And then the number of times I move that decimal point becomes my exponent. So it's always times multiplied by some power of 10. So my exponent becomes the number of jumps or the number of times I move the decimal point. And then you're going to write all of the non-zero numbers. And this will be a shortened way so you don't have to write those 7 zeros at the end. Now, when you move the decimal point to the left, your exponent is positive. But when I'm moving the decimal point to the right, it's going to be a negative exponent. Because remember, in lesson 7-9, we learned that a negative exponent makes the number really small. So let's go ahead and try example B. I'm going to go ahead and write it down, and then we're going to count the jumps. So 1, 2, 3, 4, 5, 6, and then 72. Okay, so now I'm going to count the jumps that it's going to take so that I'm behind a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7 jumps. So 7.2 times 10. And now because I moved it to the right to make my number larger, my exponent is negative. So this is how we're going to go from a standard form number to something in scientific. Now we're going to go the other way, where your number's already in scientific notation, and they're going to want you to expand it. So here is my first number that's in scientific notation. And what I'm going to do is I'm going to write the 4.95. And now I'm going to look at my exponent. It's an 8. So this tells me I need to move the decimal point 8 times from where it is. Okay, it doesn't mean I add 8 zeros. It means I move my decimal point 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Now, I think of those as little baskets, and I'm going to put my little eggs in here, or you can think of them as placeholders. So then now we could write our number And now we can add in the commas. So here is my number, 495 million. Then the next one, notice it's a negative exponent. So now instead of moving my decimal point to the right, I'm going to move it to the left to make a really small number. So I have my decimal here, 7.63. And now I'm going to move it 5 times to the left. 1, 2, 3, 4, 5. Put the decimal point, fill all these baskets with eggs. So now I have 4 zeros in front of my number and then the 763. So that's how you can expand it. You don't necessarily have to figure out what 10 to the 8th power is and then multiply it. Just move your decimal point. Next, we're going to learn how to multiply and divide numbers in scientific notation. Now, when it's written as a fraction in example A here, this means to divide. So what I'm going to do here is I'm going to divide the decimal part, and for the powers of 10, I'm going to apply that quotient property where I subtract the exponents. So I'm going to subtract 10 to the 7th and then subtract the exponent of 4. So my power of 10 is going to become 10 to the 3rd. Then as far as the decimal part of my number, I'm going to take the numerator. It's going in the division box and then the denominator outside. So I'm going to, again, divide this now. Again, I can bring my decimal point straight up. 2 will go into 3 one time. Multiply, subtract, bring down, and I subtracted wrong. That should be a 1. And then 2 goes into 12 6 times. So my answer here is 1.6 times 10 to the 3rd power. So when we are dividing, you are going to divide the decimal portion, and the powers of 10, you will subtract them. Now, read this.
So after we get that answer, are we going to have to move the decimal point and make it into decimal point?
I think it'll say, because this instruction said leave your answers in scientific notation. So that's how you're going to leave it on the quiz on Thursday. You're just going to leave it in scientific. Now, if you ever get a standardized test question that says, you know, put it in standard form, then you'd have to move the decimal point back. But if it says leave it in scientific notation, you leave it like that. Now, one other thing is remember that the correct format for scientific notation is the decimal portion always has only one number in front of the decimal point. If you would have gotten something like 0.16, we would have to adjust our exponent. And we'll see an example of that coming up. So let's first try the multiplication. So again, when we're multiplying, we're going to do something similar that we just did with the division. We are going to multiply the decimal portions, because now we're multiplying. And then remember, with the exponents, when you multiply, you add. So here I'm going to add the tens. So the 10, it becomes 10 to the 5th. And then I actually have to multiply 2.5 times 6. So here I'll multiply 6 times 5. And then 6 times 2. Has one decimal place. So now I have 15.0 times 10 to the 5th. Now, like I just stated, you can't have two numbers in front of the decimal point for correct scientific notation. So I need to adjust this. So my thinking or my trick here is, if you're going to make the number, the decimal portion, smaller, however times you move the decimal point, that's how much you have to add to the exponent. So I need to move this one time to make this 1.5. So because I moved it once to make it smaller, I'm going to add 1, the number of times I moved it, to the exponent. So the final answer here is 1.5 times 10 to the 6th power. Now, if my decimal was 0.15 times 10 to the 5th, notice I would move it 1 time to make it bigger, so then I would subtract 1 from the exponent. So however many times you move the decimal point to get it in the correct form, that's what you're going to add or subtract to the exponent. So this one would have become 1.5 times 10 to the 4th, if that was the decimal you got when you multiplied. So notice option C here, or example C. Notice it's not in the correct form. So we need to adjust this. So right now I'm at 4/10 times 10 to the 6th power. Remember, correct format is going to be 4.0, or just 4. So I need to move it 1 time, and because I'm making that get bigger, it's going from 4/10 to the whole number 4, I'm going to make my exponent smaller by subtracting 1. And that would be the final answer there. We do have one word problem example here. So let's go ahead and try that one. So here it says the distance from the sun to Mercury is approximately 6 times 10 to the 8th kilometers, and the distance from the sun to Pluto is approximately 5.9 times 10 to the 9th kilometers. It wants us to find the ratio of the first distance to the second distance. So the first distance that was given to me was the distance from sun to Mercury. So I'll go ahead and write that in here. So 6 times 10 to the 8th. And then the second distance was the 5.9 times 10 to the 9th. So we need to simplify this ratio. So again, remember, for the powers of 10, we're going to subtract them. And this is going to give me 10 to the negative first power, because I'm doing 8 minus 9. That gives me negative 1. And then for the decimal portion, I need to divide them. So I'm going to put the numerator in the box, 5.9 outside. When you divide with decimals, you're going to move this once. So I move it once in the division box. And then here, actually I can just leave it as a fraction. They want it as a ratio. So let's just leave this. So what we could do here is deal with this as 6 over 5.9. Might be easier to do it this way. So 6 over 5.9 times 1/10. And then when I multiply this, it's just gonna, when I multiply 10 times 5.9, it'll move the decimal point, and it's 6 over 59. It'll be easier to do it that way instead of dividing it, because they wanted it as a ratio, not in scientific form. So if they wanted in scientific notation, I would have divided it, but they just wanted it left as a ratio. Let's try the next example. They're talking about expanded form. And you won't have this on the quiz. So actually we could, let me see, however, let me go ahead and rewrite it. So it says to write each number in expanded notation using powers of 10. So example A is the number 8,572. So if I write this in expanded form, I could break it apart. So it would be 8,000 plus 500 plus 70 plus 2. This is probably something you might have done in 3rd grade. I know it was a long time ago. So if I expand this, and now I'm going to add in my powers of 10. So over here, if I start backwards, we know anything to the 0 power is 1. So for the 1's place, you're going to do 2 times 10 to the 0. And for the 70, it would be 7 times 10 to the 1st. For the 500, 5 times 10 squared. And for the 8,000, 8 times 10 to the 3rd. So that's how you would write it in expanded notation using powers of 10. For example, B, do it up here. It's now a decimal, so 3946. So if I go ahead and first expand this, this is going to be 3/10 plus 9/100 plus 4,000, 100,000ths, or 100. And then here, the 6. And 0,006. Now for powers of 10, remember when you have a decimal, we're going to have negative exponents. So this is going to become 3 times 10 to the negative 1 plus 9 times 10 to the negative 2. It's like a count up now, but it's with negatives. Plus 4 times 10 to the negative 3 plus 6 times 10 to the negative 4. And you're done. Then for part C, it's a combination of both. So 25 and 300ths. So again, if I expand this, it would become 20 plus 5 plus 0/100ths or 0/10ths, and then the 300ths. So now with the exponents, this is going to become 2 times 10 to the 1st plus 5 times 10 to the 0. Plus 0 times 10 to the negative 1, just so you hold everybody's place. And then 3 times 10 to the negative 2. So that's how you would write it in expanded form. Now, coincidentally enough, when we were first doing these ratios, we actually had conversions. So here are more of the conversions. Again, your metric system always uses powers of 10. So whenever you want to convert within the metric system, you're either multiplying by 10, 100, or 1,000, or dividing it. Or you could also think of it as multiplying by 1/10, or 1/100th, or 1/1000th. So to change from kilometers to meters, I know that there are 1,000 meters in a kilometer, so I would multiply 1 kilometer times, it would be equivalent to 10 to the 3rd meters. Or you could say 1 kilometer equals 1,000 meters. And then here, if we went the other way, there are actually 1,000 milliliters in a liter. So this would be represented as 10 to the negative 3. So instead of a positive exponent, we now have a negative exponent. So here it would be 10 to the negative 3 liters. You could also represent it like that. So that is the conversion with the metric system, showing how you could use your powers of 10. Again, when I teach the metric system, I teach that little acronym. King Hector drinks basically delicious chocolate milk, and then you can just move your decimal point. But however many times you move your decimal point, that would be your exponent. So this is how we could tie that little acronym into scientific notation. So your homework for the scientific notation is going to be 1 through 32 all. And then tomorrow we'll go over these answers and then review for your quiz. So we're only going to cover 2 lessons for this week's quiz. Any questions? Okay, so you don't have too much time, maybe about 2 minutes. But if you don't have any questions, you could, I guess, start gathering your things and head on out to Carline.